So today we are in week 3 for basic statistics in R. So we will start with probability today. So go in week 3, we have this file. So I will start with week 3. Okay. So introduction to probability. So I think you already have studied probabilities in your school days. So quick recap and a bit of advanced topic that is required during data analysis. We'll cover that. So starting with probability is a long run relative frequency. Relative frequency means uh, in terms of total frequency, if for example if we are tossing a coin, so coin will have either head or tail, right? So relative frequency means if it is head, then it will be a 0 0.5, 1 by 2, or tail it's 1.5. So it gives us the relative result. So that's why it's a relative frequency. That's why we call the probability as a relative frequency. Then it comes like how do we calculate frequency? How do we calculate probability? So before calculating probability, we do experiment. Okay, so experiments are operation carried out in order to find something or to test some hypothesis. So what does that mean is, so if we are unsure of something, then we need to do an experiment which gives us some output, like whether the experiment is true or false. For that we do hypothesis. Okay, so for any experiment we do, either if we can succeed or we can fail. Okay, so for that we test our hypothesis. And randomness is the outcome that cannot be precisely predicted. Like if we are not able to precisely predict the outcome, that is what the randomness is, right? So random experiment means a process of yielding a result based on the random data that we have. Likewise, event is any outcome of an experiment is known as event. For example, we toss a coin, so outcome can be either head or tail. So that is an event, right? And sample space is all possible outcome of an experiment. So all possible outcome, for example, if we toss a coin, all possible outcome will be either can be the head or tail. So if we toss our dice, if we throw a dice, so dice can have either one or two or three, four, five, six, because dice has six faces, right? So this six, this output is this is our sample space. Okay, so this is also our sample space. So it is denoted by omega p omega. So this is what sample space is. So let's say, for example, if we throw a dice, so throwing a dice is our experiment. Okay,
Mm.
and sample space is all possible outcome. So 1, 2, 3, 4, 5, 6 is our sample space. Event is for example, in while throwing a dice, what is the chances of getting a even dice? So even dice can be 2, 3, and 5, right? So this is my event, and probability is this event divided by total event, right? So event divided by sample space. So 3 divided by 6, which is 1 by 2. So this is my probability. Okay.
Mhm.
Any question here?
No, no, it's fine. It's
Yeah.
simple.
Okay. So rules of probability is, so the probability always lies between 0 and 1. So my probability should always be 0 and 1, between 0 and 1. And sum of probabilities of all the sample event in the sample space should be equal to 1, right?
Mm.
So if you toss a coin, it is 0 0.5 is for head, 0 0.5 is for tail. So 1. So it should not exceed above 1, right? So
Mm.
this is the rules of probability. Then it comes the law of large number. This is often asked in interview, like what is the law of large numbers? Okay, so a law of large number says is as the number of trials or observation increases, The actual or observed probability approaches to theoretical or expected probability. What does it mean is for example, if we toss a coin, then the probability of head is 0.5, right? So this value is the theoretical value, theoretical theoretical probability. Okay, so the actual or observed probability approaches to theoretical or expected probability. So the actual or observed probability is what that we do based on the testing. For example, this is the dice that we throw on one attempt, right? So if we again in second attempt or third attempt, like out of, suppose if we check on 100 attempts, then what would be the probability? So if as the number of attempts increases, the theoretical probability approaches close to the observed or empirical probability or actual probability. Okay, so we will see this example in Excel, and also we will implement the law of large number in R. Okay, so what does it tells is like whatever the experimental probability or observed probability that we get, as the number of trials or observation increases, value of n if increases, then the actual or observed probability approaches to theoretical or expected probability. Theoretical probability is what we usually assume, like for example getting a head will be 0.5. For example, getting a dice will be getting a dice will be 1 by 6. Getting one dice is 1 by 6, right? So this is what theoretical. And if we do experiment of setting a number for 100 sample or 1000 sample, so that is the experimental or empirical probability, right? Or actual or observed probability. So that says, so if your limit of n approaches to infinity, like you can say like your infinity, or we can say some number approaches to infinity or number, your probability becomes a theoretical probability becomes really close to your observed probability. Okay, the theoretical probability becomes close to observed probability. So this is what a law of large number says. So your sets are the collection of items. So sets can be a union, mutually exclusive or disjoint or independent events. Okay, so what does this means is mutually exclusive means your of A intersection B is 0. P of A intersection B is 0. That is what uh, mutually exclusive means. So we'll come into this topic later. Okay, so law of total probability is this one. So law of total probability, this is also often asked in interview question. What is law of total probability? So law of total probability is the probability of event A. So for example, if you need to calculate the probability of event A, then probability of B times probability of A given B. So how do we read this? As suppose if we have P probability of A dash B here, this means how do we read this is probability of A given B. This is how we read this sign. So likewise, P bar means not belonging to B, probability of A not belonging to B. So this is the formula for calculating probability of A. Okay, so I will give you an example of this. So let's say for example, an insurance company believes that people can be divided into two classes: those who are accident prone and those who are not. Okay, so let's say, so what is the question? An insurance company believes that people can be divided into two classes: those who are accident prone and those who are not. Okay, so here if we draw a tree diagram here, what we can say is the insurance company can be either accident prone. So let's say A denotes accident prone. Okay, and suppose A bar denotes those who are not accident prone. Okay, then the statistics shows that an accident prone person will have an accident at some time within a fixed 1 year period with probability this. Okay,
Mm.
so accident prone will have within 1 year will have will have accident prone will be accident prone, and it has chances of
Mm.
0.4, right? And likewise, whereas this probability decreases to 0.2 for a non-accident prone. Okay, for non-accident prone is the non-accident prone. Okay, so for non-accident prone, the probability decreases to
0.2.
0.2 after 1 year. Okay, and then if we assume that 30% of the population is accident prone, okay, so this is 0.3. Okay, then this will be 0.7, right?
7.
Because total is 1.
Yeah.
What is the probability that a new insurance holder will have an accident within a year of purchasing a policy? Okay, so what it says is, so find the probability that a new policyholder will have an accident within a 1 year of purchasing a policy. So let's say B denotes
New.
the new policyholder who is accident prone. Okay, so then what would be the probability? The one who has accident. Okay, so law of total probability, what it says, who has accident plus those who don't have accident, right?
Mhm.
So this times this 0.3 times 0.4 plus those who don't have accident 0.7 times 0.2, right? So this is what the law of total probability says. So probability of A here A is this. So we are calculating probability of B. Okay. So probability of B will be equals to probability of A times probability of
Mm.
A given B. Okay. This is this plus probability of A complement times probability of A given B complement, which is this. Right. This time this time this. So, so this is how we calculate total probability. Okay.
Mhm.
Any question here?
No.
Okay. So joint and marginal probabilities. So we will come into this later. And joint probabilities are the intersection of certain outcome of the variable. So if you look at Venn diagram, so joint probability will be this part. Okay.
Okay.
So if we look at contingency table, so in contingency table we discussed last or previous week contingency table. Okay, so in contingency table we took uh, questionnaire, and it was like how many weights eating chocolate consumption,
Mm.
eating chocolate chocolate. Okay, so 20 kg student ate like 20 gram of chocolate, 80 kg student and 60 kg student ate something 30 gram or 80 gram. So here we have the value. Here was the value, right? So this value is joint
Mm.
joint probability. Okay, and here that we had the result, the output total here, this one, This one is what we call, this is the marginal. At the bottom we have this. This is called marginal probability. Okay. Now comes the conditional probability. So conditional probability is also very important, and it's been asked in interview. What is conditional probability? So conditional probability is concerned with the idea that the probability of an event occurring may depend upon whether certain other events have occurred. Okay, for example, so probability of passing an exam. So we can say like probability of passing an exam can be, if a, can depend upon the person, whether a person is hardworking or if he is a lazy. Okay, so this given uh, probability of passing an exam given a person is hardworking, right? So this is your condition, right? So this is your condition. So given a person will pass the exam, a person will pass the exam given the condition that he is hardworking, is definitely will be 0.8%, right? So person who is lazy will definitely fail the exam, so his chances will be very less, 0.2, right? So this is the condition, right? So that's what the conditional probability is, given on probability of passing an exam. So probability of passing an exam given student is hardworking. Okay, hardworking. Okay, so if we denote hardworking as H and passing the exam as P, so it is generally written as P passing the exam given the person is hardworking. So this bar denotes given. Okay,
Given.
given. So this is the formula for calculating conditional probability. Probability of A given B, probability of A given B, probability of A intersection B, A equals B is A and B is known as probability of A intersection B divided by probability of B. So this is the formula for conditional probability. Okay. So probability of A given B. So here you can see that your denominator will always be this part. So if it is B, the denominator will always be B. Okay. So here if you can see in this example, this part is what is called intersection. So here A intersection B means common part between this and this, right? So this value, if you see in this table,
Mm.
this value is all your intersection part, your intersection part. Okay,
Mhm.
so this is intersection divided by this. Okay, so now let's jump into one example. Okay, you are rushing out to get to your interview in 30 minutes. Okay, from experience you know that most of the time you travel this distance in 30 minutes. So based on your experience you usually reach your office at 30 minutes, let's say. Okay, however, half of the time there is high traffic. So even if in your, based on your experience, uh like say 10 times if you reach at office, five five times you encounter traffic, you encounter heavy traffic. Okay, in the past there has been heavy traffic and you have made it to the appointment within 30 minutes, 34% of the time. Okay, so you get out on the street and see that there is heavy traffic. What is the chances you will get to your appointment on time? Okay, so read this question once and try to figure out if you can, if you're able to find this A intersection A and B is any part. If you are trying, if you can figure out, try to read this question once and figure out.
Get your appointment. Actually, you know that most of the time you travel this distance in 30 minutes. You will walk all the time. That time heavy traffic in the bus. Heavy traffic when you have made it to your good and 30 minutes. Distance that you have after the 34%. So you get out these students here, you will have to means you will get to your appointment on personal knowledge. 44. 50% divided by 34%. Is it what it is?
So, so you're saying how to get to an appointment in 30 minutes. From experience, you know that most of the time you travel this distance in 30 minutes. However, half of the time there's heavy traffic. So if we consider PH as heavy traffic, then half of the time there's heavy traffic. 0.5 of the time is heavy traffic. Okay, so
Mhm.
your PH is 0.5. So in the past there has been heavy traffic and you have made it to the appointment. Given that you have heavy traffic, you have made it to an appointment. So this appointment is A. So you have made it to an appointment given you have a heavy traffic is 34 0.34,
Yeah.
right?
Yeah.
So okay, so what is the so the chances that so you get out on the street and see that so there's heavy traffic. What are the chances? Yes, you will get to appointment on time. Okay, so we need to find P of A, right?
Yeah.
So we know conditional probability of given by P of A intersection B. So P of A given, so here is what is given is this. So you get out on the street and see that so there is heavy traffic. Okay,
Mm-hmm.
and what is the chance that you will
Get
get to your appointment on time? Okay, so this is given and this is given. Okay, P of H is given. So we need to find this part. Given that if you're out on the street and see that there is heavy traffic, P of A intersection H is 0.34 times 0.5. This will be your answer.
but there has been heavy traffic and 30 minutes traffic.
You can even relate this in this way, like if you can relate this in this way, like for example, you can say this as appointment here, appointment and heavy traffic. Okay, if you relate this, we need to find this part. So this part is your This part is intersection part, your intersection part. So we need to find this part. Given that the probability of appointment, probability of so what is given?
Okay,
You
usually for happy traffic will happen
yeah,
0.5.
this is given, and appointment given that it's
Yeah, in the past means like it's one scenario where it's
probability
one
of
scenario where appoint he could appoint he could get into appointment in 30 minutes in 34% of time 34% of time in heavy traffic. So
no.
yeah.
Likewise, we have one more question. So this is a bit complex question. This so a certain pregnancy test correctly detects a pregnancy 99% of the time. Okay. Okay. Let's read this question first. So a certain pregnancy test correctly detects a pregnancy 99% of the time. Okay.
Mhm.
A test detects pregnancy 99% of the time, 0.99.
Mhm.
Okay. And that means it does not detect pregnancy only 0.01% of the time, right?
Mhm.
The same test gives a false positive result 0.3% of the time. So here is the concept of false positive. False positive means your actual value and predicted value. Yeah. 1, 0. So your actual value is also 1. Your actual value is also 1 and predicted value is also 1. Then that is called true positive. Okay. So this is true positive. But your actual value is 1. But your actual value is 0. But your prediction is 1. Then this is called false positive. Or, or test result which wrongly indicate that a particular condition or attribute is present. Okay. So that means you actually it's let me check the table.
Okay.
So yeah, so false positive is like, for example, here we can say, like, for example, false positive. False means like in case of testing, for example, pregnancy or not pregnancy. So false positive will be, for example, false and positive, right? So person, woman not being pregnant but considered as pregnant, like considered as pregnant, that is false positive. right?
Mhm.
And then negative result. This is false negative. So false means 0 and positive means 1, right?
Mm.
Positive means 1. So false means so for being fake, but it's actually not fake. Okay, so false positive. Okay, false is 0, positive means true means 1, right? So if you say like if you say woman not not being pregnant but considered as pregnant.
Mm.
Okay, so woman is not pregnant but she is considered as pregnant. That is what is called false positive.
Mm.
A
Yeah.
woman is pregnant and is considered as pregnant. That is called true positive.
Positive.
Okay, makes
Mm.
sense.
Yeah.
Okay, so this is given like this is what we. So we even have one image that will make you more clear. Okay. So for example, if you see this example, okay, so true positive is you are pregnant, like she is actually pregnant. Okay,
Mm.
true negative is, so this is a old person and he is a male, so he will not be pregnant. So that's
Yeah.
what a true negative means. Okay, and false positive means uh, so he will never be pregnant. Okay, but the doctor says that he is pregnant. That is false positive.
Mm.
And false negative is she is pregnant but doctor says she is not pregnant.
The
So
false
that
is not
that,
there.
that is false negative.
Yeah.
Okay, so here in our question what we have, so we have false positive, right?
Mm-hmm.
Which is false positive means the model is saying like he's a person, he will never be pregnant, but the model is saying that he's pregnant, right?
Yeah. Yeah.
So in this diagram he's not pregnant but he is considered as pregnant, right?
Mm-hmm.
Not pregnant but considered as pregnant. So which is 3%. So here this is 3%, 0.3%, right? So this is what 0.3% is. Okay, not but considered as positive. Okay, that is false positive. So it is known that 80% of women using pregnancy test are pregnant, right? So this 0.99 is what the chances of being pregnant is, that having positive result is, right? So this is 0.99. And what, and it is known that 80% of women using pregnancy test are pregnant. That means this is 0.8% and this is 0.2%. Okay, so let me draw a fresh diagram for you. Pregnant or pregnant, this is 0.8%, this is 0.2%. So here positive, negative, 0.3, 0.7, positive, negative, 0.99, 0.01. Okay, relate this ones with this question if that makes sense to you or not. Or you can draw your own diagram on your copy. Okay,
Mm-hmm.
try to think of it and draw the diagram in your copy.
Test correctly. 99%. All this all the time. Test gives a false positive result of 3%. Test are permanent. Test are permanent. So it basically says that like we did test pregnancy test, and then there's a two condition. One is either she is pregnant or she is not, like, right?
Yeah. So after
And,
being pregnant, what are the chances of positive result and negative result?
yeah,
Okay.
yeah, and then they go to the pregnancy test, and pregnancy test shows 0.8%, 0.8 probability
Yeah.
of getting pregnant
Yeah.
and not
So
getting.
that is, yeah. So that
Yeah.
is this part, first part.
Mm,
Okay.
mm,
And so the first part says the positive result is 0.99,
mhm.
negative result is 0.01 time, and false positive is like not being pregnant but considered as pregnant is 0.3, and this minus 1 minus if we do that is 0.7.
0.7 means that like
This is false negative.
false negative. False
Yeah,
negative means like they are
false negative.
pregnant but then result as not pregnant. Is that true?
So false
Like,
negative,
wait,
false negative, if you see in this diagram is,
false
so she is pregnant but she is not considered as a pregnant, but doctor says she is not pregnant.
not pregnant, right? Ah, okay. She's pregnant, but alright, yeah, makes sense. And true negative. Yep, true negative means not pregnant at all. Yeah, pregnant. False.
So I will save you this link.
Yep,
So
got it.
okay, so yeah, you are
Yeah.
temporarily blocked. Uh, okay, you can view this example if you type
Mm,
here.
okay.
Search, yeah, search image. Okay. Mhm. Just give me 1 minute. Okay?
Mm,
And battery is running low.
okay.
Okay. So now we need to find if the test shows a negative result, so given our test, if it shows the what is chances that woman is pregnant? Woman is pregnant given the test shows negative result. We need to calculate this. Okay, first probability of what is the test shows a positive result. What is chances of woman not being pregnant? Woman not being pregnant of showing positive result. This we need to find out. So what we need to find?
If pregnant, but so negative result. If not pregnant, so positive result.
Says negative result.
Not
Not pregnant and shows
positive result.
positive result. Okay. So for that, first what we need to do is we need to find positive result. First we need to find first we need to find negative result. Okay, because the formula of P of negative is probability of P intersection negative divided by P of negative, right? So first we need to find P of negative. So P of negative is we need to use law of total probability, okay, which
Mm,
is 0.8 times 0.01 plus this times this and this times this, 0.2 times 0.7, right?
that
And
is
then we need to find this probability of A into P intersection negative is intersection negative is this times this. So 0.8 times 0.01 divided by 0.8 times 0.01 plus 0.2 times 0.7. So this will be probability of P being probability of being pregnant or shows negative result. This would be the formula.
yeah.
Okay. So is this formula making sense? Because here we need to find first we need to find probability of getting negative result.
Mhm.
So for that we need to use a law of total probability, which is this times this. 0.8 times 0.01 plus 0.2 times 0.7, right?
Mm,
And then probability of once we get this, probability of A intersection negative is this times this. Probability of A intersection negative is this times this. Okay, 0.8 times 0.01. So we need to divide that. Okay. Okay, try to find the second one by yourself. What would be result?
mm. 0.2 into 0.3 by
Okay, see here. So it will be 0.2 times 0.3 by
0.2 times 0.3 plus
0.3 plus,
0.8 into 0.99.
yeah, that's correct. Yeah, that would be the answer. Okay. So then we have Bayes law. So what we did right now is what the Bayes law says. Like Thomas Bayes proposed the following theorem to determine the probability of an event given the occurrence of a prior event. Okay, so this is right now what we did is called Bayes law. So probability of A given B is probability of B given A times probability of A divided by probability of B. So this is the formula for Bayes law. So if we search in internet, uh,
Bayes.
why this is popular? So if we look at Bayes theorem, Bayes rule, okay. So this is what. So probability of A will happen given evidence A has already happened. Okay. So probability of A will happen divided by probability of B will happen. Probability of B will happen given evidence B has already happened. So this is the formula, but you don't need to remember this formula. So if you remember, just try to understand this formula. But if you remember this tree, if you try to make up this tree, then you don't need to remember this formula, because this is this is what we call, if we did this times this, right? So this is what we is called probability of key given probability being positive, right? So
Mm,
this times this is what are the what we did based on this formula, right? So this times this divide by probability of B, which is positive, right? So this is the same formula that we have applied here. So whatever we calculation we did, so it is the same that Bayes law says. Okay. So we don't need to remember this formula, but we need to keep in mind, like what does this mean?
mm,
So probability of A given B is probability of B given A times probability of A divided by probability of B. Okay. How does this uh, came true is because the conditional probability of conditional probability is probability of A given B is probability of A intersection B divided by probability of B, right? This is the formula for conditional probability, right?
mm, mm,
Probability of A intersection B will be equals to probability of A given B times probability of B, right?
mhm,
Also, what is said like probability of A given B is equals to probability of A intersection B divided by probability of B, right? Likewise, probability of B given A is also equals to probability of A intersection B we do or B intersection A we do. Both are same, right?
mhm,
Divided by probability of A, right? So here if we again we do P of A intersection B, then probability of B intersection A times probability of A. This becomes, so this and this is equal, right?
mhm,
This and this both are equal, right? So what we can do is then probability of A into A given B times probability of B is equals to probability of B given A times probability of A, right? So here we again probability of A given B will be equal to probability of B given A times probability of A divided by probability of B. So this is how this formula came up. Okay. So this is the first step, second step, third step. So this and this both are equal. So we equate the third and fourth, second and fourth. This and this becomes equal, right? And then this formula is derived. Okay. So let's do one more example.
Okay.
So consider the urn containing five green ball and three red ball. So we have five green ball, green ball and red ball. Okay, five green ball and three red ball. Two balls are drawn. The first not being replaced. So in we have a bucket here of green ball and red ball. Okay, so randomly two balls are drawn. The first not being replaced. Okay, so once we draw one ball, so for example green ball, so it is not being replaced again.
Mm,
It's not being replaced. Okay, suppose that the second ball drawn is a green ball. What is the probability that first ball was a red ball? So this is what we need to find. So this is the first one. So first time the probability of green was 5 by 7. 5 by 8, sorry. 3 by 8, right?
mm,
Second time what happens is once the ball was drawn, it was not replaced, right?
mm,
So green 2 if we do and red 2 we do, it was not replaced. That means
means
7. 1 is missing here, right? So 4 by 7,
4 by 7.
right? And again, in terms of red 2, this will be 2 by 7, right?
Mm.
So this will be 7, 3 by 7, and this will be 5 by 7, right? Okay. Try to read and draw the picture.
The second one is green. What is the first one was a red one. Wait. Consider suppose the second ball is drawn is a green ball. First No, not ringing the bell. It's a simple one, but I'm not ringing the bell.
So okay, so were you able to draw this diagram, this tree
Yes,
diagram?
yes, but I didn't understand the concept. I draw the diagram, but
So okay, let me tell you. Let me repeat it again. Okay, so we
not
have two balls. Okay,
too much.
one is green and this is red. Okay, so probability of green is 5/8, 5/8, right?
Bad.
Red is 3/8. Okay, so two balls are drawn, the first not being replaced. Okay,
Yeah,
so in
draw.
a bucket we have green ball and red ball. Okay, so anytime two balls has been drawn, okay,
Mm,
one not being replaced. Okay,
yeah.
so once we take out the ball, we don't replace that again. We don't replace that again. Okay, so in second attempt, okay, so if we don't replace one ball, suppose from here, so our probability will be 4/7, right?
4/7.
4/7 for getting green ball. Okay, so in second attempt, probability of getting red ball will be 1 minus 4/7, which is 3/7, right?
Mm.
Likewise, in second attempt, if we draw a red ball, so one is gone. Okay, so it becomes 2/7 here. Okay, one is
But
gone. 2 by.
my concern is like Red Bull was the first one, right? We draw.
So it can be, for example, it can be either red or green. So in first
Oh
attempt,
yeah,
first
yeah, yeah.
first
That's why
attempt,
we are here to find the probability of finding red, right?
this is for second attempt. Yeah.
Now I get it.
So this will be 5/7. Okay. Now
Yeah,
the question is, suppose that the second ball is a green ball. What
mm,
is the probability that first ball will be a red ball? So we have
red
to
ball,
find probability of red ball, first being red ball, given that second is G2. Okay.
yeah, yeah.
So we need to find this one. G1 given G2. This times this. Okay. So try to find what would be is probability of R1 given G2. What would be this?
Mm. 7/8 into 4, plus yep. G2 is 4/7. 5/8 into 4/7. Ah, mm, we are finding. Yeah, we need first R1. R1 intersection G2, right? Probability of R1 intersection G2.
So this times this 3/8.
3 by
3 by
8.
8
Mm.
times 5/7 divide by
Oh, yeah, yeah, yeah. Divide by mm,
total G. We need total G.
reason
Total G2. Okay. We need total G2, which is this times this
of 3 by
5,
8
5
times 5/7
plus
plus 5
this
by
way
8 times 4 by
5/8 times 4 by
4 by
7.
7.
Yeah.
5 by 9, 3 by 10. Oh, 2 by 7. Total. Oh, okay, okay. 4 by 7, 5 by 7. And then G2 means Okay, okay, okay.
So I have few practice questions for you.
Mm-hmm.
Mm, So so okay, so let me complete this part of also. This part is remaining. So example of a law of large number will be, so what is law of large number? Theoretical becomes equals to your empirical or actual value, right?
Mm,
So if we consider an observation, let's say, okay, so 100 observation here, if we consider 100 observation, right, the probability of getting head and tail will be here. So I have used here choose, I have used because this choose will always give one. If this is one, then it will be head, and if it is tail, then it will be two, right? That's why I have used choose here. And here I have used random number between 1 and 2.
mm,
Okay, so I have calculated probability. So we know that the probability of getting head or tail will be 0.5, right?
mm,
Okay, so here in 100 observation we got, so total probability of head. So I have done count if, okay, count if this is 1, then it will check the count if of your of this column, if this is equals to 2. Okay, so this is the count of 1 and this is count of 2. Okay,
mm,
and then this is the probability. Okay, so here you can see your probability for 100 sample is 0.52 and your tail is 0.48, so it's near about 0.5, right? If we
okay.
look at 100 observation, it is somewhere around 0.476 and 0.52. Okay,
Mm,
if you look around 10,000 sample, it is close to 0.5, right? So what's the conclusion is, so for 100 your our theoretical is always 0.5,
yeah.
right?
Mm,
So what's the conclusion for 100 sample? Your observation is you have 0. Minus 0.02 error. For
mm,
1000 you have more small error, right?
mm,
For 10,000 you have more small error. So as your value of n increases, your theoretical observation becomes equal to your actual observed
actual
value.
observation, yeah.
So this is what the law of large number says.
Mm,
Yeah. So this is law of large number. So theoretical value becomes equals to. So this is changing because the number are random. Here we have taken random number, so the
mm,
numbers are changing. So theoretical becomes equals to observed value as the number of sample increases, right?
mm, mm.
So if we do this in R, this is making sense, right?
Yes, yes, this one.
So if we do in R, let's say, so let's say my number of sample is 100. I have taken 100 sample, okay, and I have stored the result in data frame, okay. So my observation is sample of 1, 2, or 2, because 1 will be your head and 2 will be your tail,
Mm,
and the replacement is true. Let's say replacement is true. So then your head will be sum of. So if you look at now, if you check x, then so you will have 100 records, 100 sample with value 1, 1 or 2, because
mm.
we have given the sample as 1 or 2,
1 and 2.
1 and 2, and replacement is true. Why we did replacement is true? Because replacement true will give us the random result. That's why we did replacement equals true.
Okay.
So if so, your head will be, so your total head will be the sum of your x up to your observation, that is equals to 1. Okay, will be your head, right? Count, total
Mm,
count. Likewise your tail will be So mass of observation
two.
equals to, okay, and your total probability will be probability of head will be head divided by head plus
Two.
tail. Okay,
Yeah.
so probability of tail will be tail divided by.
Yeah.
So if you run this,
Oh,
okay, so now if you check probability of head, so it is 0.63. Okay, and your probability of tail is 0.37. Okay, so
mm,
let's increase to 1000. Let's see. It increase to 1000. Then the probability of head is 0.54. Okay,
mm,
it's more close to 0.5, right? Like
yeah.
0.9. Okay, it's more close
Mm, mm.
to
0.5.
0.5. Let's do 10,000. The probability of head is, it's now more closer, right?
Mm,
So this is what the probability of law of large number says. Okay. As your sample size increases, your theoretical value becomes equal to
actual
the
observation.
observed value. Yeah. So yeah. So I have quiz for week 3. So if you can see here, you have some sample questions for you. So if you try to solve this question, then you will have a basic understanding of probability, conditional probability, and Bayes theorem. Okay, so have a look at these questions,
Mm-hmm.
mm, and try to solve these questions. Okay, so now let's take a 5-minute break and then we will start with Python.
Okay.